Find all the values of theta between 0 and 360, satisfying the equation 7 sine squared plus 1 equals 3 cos squared minus sine theta. So here, what have we got then? We've got a trigonometric equation. We need to solve between 0 and 360, as we said. We've got sines in it, and we've got sine squareds and cosine squareds. Because we've got a sine in it, we can get rid of this cos squared in terms of sine squared, and we can get a quadratic in sine squared, can't we? So here, we've got 7 sine squared plus 1 is equal to 3 cos squared. We can replace that by 1 minus sine squared, can't we? If I can write it correctly, minus the sine theta. So what have we got then? We've got minus 3 sine squared. Bring that over there to add to the 7 to make 10 sine squared theta. Then we've got our minus sine theta. Bring that over as well. Plus sine theta. Numbers, we've got a 1 here, we've got a 3 here. Bring that over, it's minus 2. 1 minus 3 is minus 2. There's nothing left to move over. So we moved the minus 3 when we expanded the bracket to plus 3 and added it on here. We then moved the sine over to plus sine over to the left hand side, and then we had a 3 here, move it over to minus 3 when we expanded the bracket. 1 minus 3 is minus 2. Now hopefully this factorizes. I'm going to guess it's going to be 5 and 2. 10 and 1 is probably too big. So 5 and 2 sine theta. Yes, now if I put the 2 with the 2, I'm going to get 4, and I'm going to get 1 with the 5, and the difference would be 1. The 5, this is positive, so the bigger number must be positive. The 4 must be negative. So this tells us then, let's just check we've factorized correctly. 10 sine squared theta plus 5 sine theta minus 4 is 1 sine theta. And then the last term, minus times plus is a minus, 2 ones are 2. So that looks fine. This first bracket tells you that sine theta is equal to, it would be 2/5, wouldn't it? 2 over 5. And the second one tells us that sine theta equals, it's got to be minus a half, isn't it, here. So if we look at this first solution then, let's draw a circle. Let's write cast. Now sine is positive here and here, so draw 2 lines and mark off the angle to the horizontal and label it alpha, and write sine alpha is equal to 2/5. So now we know that alpha is equal to arc sine or shift sine 2/5. So we need to tap that in the calculator to get alpha. So let's do that then. Shift sine, make sure we're in radians mode. So it's shift sine of 2/5, which we can write as 0.4. We're in radians mode, but we're working in degrees, aren't we? So I'm going to click over to degrees. 3, because we're not in radians mode at all. 23.57. So let's do the 2dp. 23.58. 23.58 degrees. So there we are, there's alpha. So theta then? Well, the first theta will be around to here. So theta is equal to, it will be around here, around the alpha is 23.58 degrees, or theta is equal to, and the next one will be around here to 180, back the 23.58. And that's the other value of theta. So 180 take 23.58 is 156.42, and you can tap it in the calculator if you need to. 180 take 23.58, 156.42. So that's that one done then. Now we look at the other one. Here let's write cast again. Let's write our circle, C-A-S-T. This time sine is negative. Sine is positive here and here, so it's negative there and there. 2 lines to the horizontal. Mark off the associated acute angle alpha and write sine alpha as a half. So that tells us that alpha is equal to shift sine of a half, 30 degrees, isn't it? So there's 30 in here and 30 in here. So our solutions, well, we need to go around 180 plus 30. So theta is equal to 210 degrees. And the other angle is round, all the way round to 360 and back 30 degrees. So it's 330 degrees. And there's also all our solutions between 0 and 360.